We're going to follow the same format that we've been using for a little while now, which we think works pretty well. We've got Tom sharing with us today about Amazon Athena, and going to give us a bit of a deep dive into it. I've gone as far as using it and experimenting with it and being able to see it work, which is really good, but I don't really know a lot about how it really works under the hood. So, so looking forward to Tom being able to share a deep dive with us. After Tom's talk, we're going to have a community marketplace, which is an opportunity for people to share in the community. You might have an open source project or something you're working on that you want to share, or you might have a conference or a talk coming up that you want people to come and attend. You might be looking for work. So you can have a 60-second pitch about who you are and what you want to do and what you're offering. Or you might be someone that needs some resources and some help. So you can put a pitch to the community. So we'll offer that as an open mic, basically after Tom's talk this evening. So you should think ahead now about perhaps what you might want to talk about or share or whatever with the community. And we'll open that up after the talk. So with that, we'll hand over to you, Tom, and you should be able to share your screen.
Awesome. Just bear with me.
Encourage people to use the chat window as well as Tom's presenting. If you've got some questions or things that come up, then yeah, we can have some breaks or whatever to try and answer any questions you've got using the chat window throughout the talk.
I'm just having first time sharing Zoom, funnily enough. So I might have to. It's coming up?
Yep.
Oh, fantastic. I was getting some security prompts with my Mac OS, so I'm glad you can see it. All good. Cool. Well, well, thank you, everybody. Thanks for taking the time after a long day, probably in front of a Zoom call, as we were just talking about. Thanks to Harmeet and Tim for having AWS here today. So over the next 30 to 40 minutes, I'm going to give you a bit of a view on Amazon Athena and a look at some of the new features that are currently in preview and public preview for around Amazon Athena. Certainly, you know, when you look at AWS and the portfolio of services that we provide to customers, you know, there's a rich ecosystem here that we provide to customers to really have that full flexibility of meeting or delivering services and removing heavy lifting relevant to the use case that you're looking to achieve. And so there's a rich ecosystem from services to help you move your data, store your data and control or provide the right access controls and data discovery capabilities for your data that's stored in AWS. And then moving up the stack into how you go about processing your data and using your data to gain those insights. And, you know, applying that through either from an analytics perspective, some advanced analytics, but also into the machine learning aspect. Today, what we're going to be focusing on is Amazon Athena. So it's one service that we see many customers use that's available within the AWS ecosystem. So what is Amazon Athena? So Amazon Athena is an interactive query service that makes it easy to analyze data using standard SQL. Now, a couple of key things here around Amazon Athena itself is it's completely serverless. So for you as a data engineer, you can essentially write or bring your SQL statement, point it at the right data repository that's defined within in your catalog, and run that standard SQL query against that data. Under the hood, it's a combination of technologies, but essentially it's built using Hive from Metastore and also Presto, which is an open source framework that's been made available through open source by Facebook. which is quite popular with many data engineers. So, so what we're providing here is essentially the ability to perform ad hoc queries against data that's residing in S3. So this is really quite powerful for organizations who are looking to enable their various different groups within the organization to run SQL queries against data assets and data that's residing in your S3 or data lake, and performing that ad hoc query and exploration against those data sets. So it's a couple of great things around Amazon Athena is it's pay per use. So as you know, typically from a serverless perspective, we only charge you for actually using the service. So from that perspective, we charge them $5 per terabyte per month of the data scanned or queried. Now, there's lots of optimizations within Amazon Athena to help you reduce those costs, supports full partitioning to help you push down predicates down from a query perspective, but also enabling you to compress your data. And so if you're storing your data in a compressed format and or in a columnar-based format, you can again optimize your queries to perform optimally, but also reduce those costs as well. So at the end of this, I've got a great blog article, top 10 tips of using Amazon Athena that I'd encourage you to look at to just get those a little bit more insights around some best practices around using Amazon Athena there. So Amazon Athena, when it was first launched, you know, I think the use case that really stuck out and resonated with customers was this ad hoc query use case, where essentially, you know, we have our data stores on the left-hand side of the slide here, and we're utilizing AWS Glue, which provides 3 capabilities, some of which are a schema discovery and a Hive metastore. Enabling us to essentially start to centralize or provide a central data catalog for our services to consume. And on the right-hand side here, you know, our customers have that flexibility to choose the relevant services depending on those use cases. And so from Amazon Athena perspective, you know, we see it sitting alongside other services like Amazon Redshift, which is our petabyte scale data warehousing capability, or Amazon EMR, which is managed Hadoop and managed Spark capabilities. And so Amazon Athena provides that serverless experience, as I mentioned, but also presents or provides a JDBC endpoint for customers to be able to point their BI tools, so whether it's Tableau, QuickSight, or others, into Amazon Athena, and enabling you to query directly data that's being ingested from those data sources on the right into from Amazon S3. Now, alongside that, we've also seen some other use cases for customers, you know, looking to apply Amazon Athena. And so, you know, one of the great things I love about AWS services is, you know, the service may be released with a particular use case in mind, but it's not until we actually put those services in the hands of developers, builders, engineers like yourselves that we see some really interesting use cases be applied to those services. And so, I'm going to step through a couple of those just to give you a bit of perspective on what else we're seeing customers use it with. So from a SaaS use case, it doesn't really have to just be a SaaS use case, but really enabling you to bring that longer tail data set to enable, say, a mobile application or a web application or an API call to be able to query data that might be stored within a data lake that's on S3. And so, you know, typically you might, from an mobile application perspective, you might have your most recent data or hot data being stored in a NoSQL environment or even a relational environment, database here, but enabling you to also, you know, start that archiving or that longer term storage capabilities into colder storage like Amazon S3. Now, Amazon Athena enables you to bring that capability where essentially, again, you know, through your mobile application, you can make a request via standard ANSI SQL to query that data and return that response into via an API call that could be being pushed into a front-end application. Now, another use case that we're seeing customers, or have seen some customers utilize, is using Athena for lightweight ETL. And so essentially this was enabled through a couple of features that were launched about 18 months ago with Athena, CTAS and insert into. So enabling you to essentially use Athena and run CTAS statements within Athena to perform some lightweight transformation and then store that back into Amazon S3. So as what's represented here within the slide, we have those various different data sources here that's being stored within Amazon S3 as your raw data or as that source data repository, and then running those CTAS statements that will execute within Athena and then store that data back as in Parquet format within Amazon S3, for which you can then point other processing tools or analytics tools at that data set. So it might be Amazon Athena, or it might be those other services that I mentioned earlier, like Redshift, for example. Now, the last use case, and we're going to touch on a little bit more as well, because some of the new features start to expand around the support and integration capabilities for machine learning, is the Athena use case around for data scientists. So I think initially, from an Athena perspective, Athena, is that ad hoc query, really simple to perform ad hoc queries. So from a data scientist, it's very easy to use the Athena service to perform SQL queries against data. So they can run Athena queries or SQL queries within their Jupyter notebooks, bring that data into a data frame for them to be able to further utilize within their training capabilities or process. We will look at additional capabilities further on in the session on how we're looking to expand this or expand Athena in the actual inference stages as well. So let's take a look at one of the probably the most exciting features that's coming or that's available within public preview within Athena is federated queries. So what's federated queries? So at the start of when I first introduced Athena and when we first launched Athena, it was really designed for querying data only that was stored on Amazon S3. So you could use point that at data that was text-based data sets or columnar-based, compressed-based file formats like Parquet, and run those SQL queries against. But what we saw from customers and what we heard was, that Athena was great because they loved the serverless notion of it, loved the pay-per-use notion of it, and they loved that how it was provided that scale capabilities for them. But they, not necessarily wanted to just always have to move their data into S3 so that they could use Athena. And so, and hence, that's the problem statement that Federated Query is looking to provide some capabilities and help customers with. So so removing the need for customers to have to move data into S3 so that they can query in an ad hoc fashion, enabling Athena to actually reach into those data stores that they have defined and execute a SQL query against that. And so as you can see here, that's represented on the slide. So Athena or Federated Query is essentially powered by AWS Lambda. And so through some configuration, you leverage some connectors that we provide out of the box for you to utilize, or you can build your own for I guess, proprietary or non-standard or yet to be supported endpoints or data sources, and use the Amazon Athena platform to run those SQL queries against those data sources. And I'll take you through in a little bit more detail on what that actually looks like in the console in a demo. But it really just enables you to start to think about what is the purpose of moving data and why are you looking to move the data, or start with the problem statement of what is the outcome that I am looking to achieve? What are those data sources that I are looking at? And not necessarily have to move that data into a consolidated data lake or into an Amazon S3 location for you to start to run your queries against or to query your data. And if you think about the typical digital landscape that we live in today and organizations live in today, when you look at the sources that data is stored in, it's so vast and heterogeneous in the technologies that are utilized. And the reason for that is developers within the domain that they're responsible for, the microservice or capabilities that they're building, you know, they're really focused, and they have that autonomous I guess responsibility to choose the tool that's right for the job. So, you know, we see microservices that are utilizing those SQL capabilities, relational capabilities. What's also represented here is, you know, we've got some order processing or data sets that are stored in a Redis cache, for example. There's lots of data stores out there that that organization utilize, and that's perfect. I think really what we want to do is we want to enable our customers to build and use tools for those right use cases. But there is also that heavy lifting from an analytics perspective of that aggregation piece of moving that data into a central repository or a data lake like Amazon S3 before you can enable some analytics to be performed on that. And hence federated queries enables you to essentially, I guess, do the inverse of that. So I touched on this in a little bit earlier. So the anatomy of federated query, excuse me, it's driven through AWS Lambda. So Amazon Athena has tight integration with AWS Lambda. Excuse me. And so essentially a connector has a one-to-one relationship with your data source. And so through our serverless application repository, we're making available to our customers pre-built connectors where you can deploy using CloudFormation templates and have those AWS Lambda functions there, enabling you to call upon those within your Amazon Athena query. And so essentially what this looks like is when you run a query, we execute the required AWS Lambda functions in a concurrent nature. And so certainly something to be mindful of as you start to dive deeper into experimenting with federated queries is to ensure that, you know, some of the things and checks and balances from a Lambda perspective, like concurrencies, concurrency limits, etc., like that. You know, you're just mindful of what that downstream query load might look like for your downstream systems. But certainly, you know, we as part of the AWS Lambda platform, manage the scaling of those connectors on your behalf. So completely serverless for you. So really simple to use. So, you know, three easy steps. There's probably a couple of half steps in here, but, you know, from a marketing perspective, it's nice and simple. Number one, and we'll step through this in a bit of this in the demo, we'll deploy a data source connector. Number two, you register the data source connector and specify a catalog name. And so that catalog name is the reference within the Athena catalog itself, that Hive catalog, where you can start to refer to that within your SQL queries. And then step three is where you have fun and you can run SQL queries and get those insights from your data. So deploying a connector, yeah, really straightforward. I mentioned we're providing templates within the serverless application repository. So think of that as a for those who aren't familiar with it, is a marketplace within AWS Lambda platform where AWS and third parties can publish some predefined serverless patterns that you can then utilize to deploy those templates, those CloudFormation templates and the code. And so AWS is making those available for a handful of data sources. So one-click deploy, and also, yeah, we deploy those connectors. And we also provide a template or a boilerplate template for you to, if you're looking to build your own connector as well for your relevant data sources. So that's a bit of a quick overview of federated queries. You know, there's no better way of getting more familiar with it than actually you know, seeing it for yourselves. And for those who have an AWS account today, you know, this is available to you to utilize. So, sorry, my authentication's timed out. So it's available for you to utilize. We will, sorry, just let me log in here. I'll step you through just a little bit. You do need to do one step to enable that public preview access into your account. And I'll step you through that first of all. But once you've done that, it's for you to start to play around with. So we'll load up into Amazon Athena here. So this is the landing page. We'll just get past that. Cool. So the first thing, that first step that you need to do to enable it within your account is you need to, first of all, be in North Virginia. So our US East 1 region at the moment is the only region that it's available in. But once it makes GA, it will be available in other regions. The other step that you need to do is you need to define what's called a work group. So by default, if you haven't used Athena before, you will have what's called a primary work group. Now, a work group is essentially a way for you to logically separate your users and define some controls and billing constraints for users or that are using the same AWS account. And so within Amazon Athena. So essentially you can set some parameters there. For the preview functionality, you need to, and this is all within the docs, you need to create a work group that's represented here. And so once you've created that, you want to switch to that work group, and you can see it up here that we're actually, I guess, assume that work group role. So once you've done that, and what I've pre-deployed today is a number of queries as part of this. So if I flick back to the slides just quickly, just to give you a bit of perspective on what my demo environment does look like. And I'll flick to the next screen. So what we've got here is a number of different locations where data is stored. So we have our Amazon Athena service here in US East 1. And down below here, we've got a number of different data sources. So this is these tables here. What I've done is I've essentially deployed the TPC-H data set, so a standard data set that you might be familiar with, and deployed those various different tables across those these different services here. So I've got a HBase environment on our managed EMR platform, or managed Hadoop platform. We have our MySQL tables and database that's stored on Amazon Aurora. DynamoDB is providing presenting some tables here, and then we'll also have some data sets on Redis Cache cluster. And so so what we're going to be doing is we're just going to be running some standard SQL queries against these environments. So if we take a look at running our first query, so what I'll do is I'll execute the HBase query. But you can see here, so it's a standard SQL query, and so you know, the user themselves, they don't need to know the interactions or the API calls that they need to be familiar with for executing or querying the data in a HBase environment. They can simply, you know, continue to use SQL, which you know, as you know, everyone loves SQL and for their own reasons. But it's a really, you know, common language that people understand, and technology based that people can interact with data around. So you know, so they can bring those same skills to be able to query those data sets. Similarly, for our MySQL environment, hang on, sorry, just having some troubles selecting. We can run a query again against that, and we should see some results returned from that MySQL database here. So in the background, Athena is calling upon a Lambda function that we have defined with some parameters, and we'll step you through that in a moment, to call upon those data sets. And finally, we'll do our Redis cluster as well, just to double check everything's working and proving there's no smoke and mirrors in this demo. Cool. So essentially, I've got a number of connectors deployed already, but what I don't have at the moment is a DynamoDB configured. So let's go do that. So the first step we take is we do a click on that connected data store. a couple of things to note here. So first and foremost, by default, you can see the querying Amazon S3 as that data location. But you can also have that flexibility to choose the data catalog or the metadata catalog that you want to connect to. So recently, we announced support for a customer managed or self-managed Apache Hive metastore. So certainly, if you are looking to integrate Athena into an pre-existing Hive metastore, that capability is now available for you to utilize. But for us today, we're going to continue using the AWS Glue data catalog. And this is where we start to be able to enable the federated connectors. And so out of the box, at the moment, we have, here's a list of all the supported data sources or data stores that we are making available to customers. For us today, as part of this demo, we're going to deploy a DynamoDB connector. Cool. And so the next step is to deploy a DynamoDB function. Now what I do have is I have deployed a DynamoDB function already. So we're not actually going to deploy one, but let's take a look at the parameters. So what this will do is now this is taking me over to the AWS Lambda service, whereas within this it's picking up this what's called the Athena DynamoDB connector application template that's available within the serverless application repository. And so within that, as part of it, and you can see the code that we're making available as part of these connectors that's available on GitHub. And so within this GitHub repo here, you can see the code that we have made available for all those relevant different connectors. We'll just let that load up in the background. So there's a couple of things when you are deploying a connector that you need to define, and it does vary depending on the connector that you're deploying. So if you're deploying, say, a connector to call upon into a MySQL environment, you need to have those connection parameter or connection string available. So the DNS name and the port, etc., like that you want the Lambda function to be aware of. For DynamoDB, we don't need to do that. So the first thing what we need to do is we need to define what's called a spill bucket. Now, the reason why this spill bucket or functionality of the spill bucket is really around Lambda itself has some parameters or execution runtime parameters that it operates in. So so essentially a function can't execute for longer than 15 minutes. And so what this spill bucket is defined for is that when your Lambda function exceeds these Lambda limits, that you're defining an S3 bucket to temporarily store the data that specific Lambda function invocation has collated from the data source. So it's a really key important aspect that there is as part of that AWS Lambda invocation, there's an S3 bucket that you also need to have available that I guess acts as that spill location. So you define a spill bucket here. The Amazon Athena catalog name. So this is the name you give you give it to represent within the Athena catalog. So for Dynamo today, what I've done for the function that I already pre-deployed is I've defined that as Dynamo. But you can define that in any which way you want. That's relevant to, I guess, the data source or the name of the data. A logic from an organizational perspective, a logical name that represents the data source. There's a few other parameters here. So there's a Lambda, some encryption capabilities, Lambda function memory capabilities. So Lambda has a support up to 3 gigabytes of RAM support, the timeouts specifications, and then a spill prefix as well for Athena. And once we define all that, you can hit deploy. But we're not going to do that today, just for conscious of time. But certainly for you, once you click that, it takes not too long for it to deploy, and then you return back into this situation, a location here. And so what we'll do is we'll just create the catalog, so Dynamo, and we'll hit connect, and we will see Dynamo that's listed as that connected data source. So if we now go back to the query editor, And we'll go back here. We should see our, why is that? Oh, here we go. My apologies. We should see the Dynamo data source up here. And while it's loading, we can run our query against Dynamo. So this is executing standard ANC SQL against a Dynamo table, which is NoSQL, and we get that return. So really simple. When it comes to running SQL statements against a NoSQL database, I think there's always been a bit of a pain point there for us to have to, I guess, readapt existing queries that you may have for other tables that you're looking to integrate into a NoSQL environment. On the left-hand side, you can see those Dynamo tables that I have defined within my Dynamo service within that region of US East 1 for this account. So we're querying that part table here that's listed here, and it doesn't expand at the moment, but you can start to get familiar with some more parameters here. So really quite simple. For the people who took note of the different queries here, so you might have wondered of why some have got lambda : MySQL, and Dynamo I didn't have to do that. And so what's happening here is you don't have to actually define a catalog within Amazon Athena. What you can do is Athena is aware of when it sees lambda or sees this string here, it knows that you want to call a connector, and it's hosted in AWS Lambda, and it will go and execute this Lambda function by this name here. So for prototyping, it really gives you that flexibility to start to prototype, build those connectors, deploy those connectors, and then when ready, you can publish those for your users to utilize. So there's some simple queries that are doing some standard select statements, one-to-one sort of queries against those specific data stores. But really, some of the exciting stuff about federated queries when you can start to bring together the data that's spread across all those different data sources. So again, a simple query. Hang on, let me try another. Oh, this might be Dynamo. Try again. Still in preview, live demo, and it starts to bring together all those different data sources. So we're getting some. It's running the query now. So again, still in preview. So you may encounter a few glitches when you're playing with it. And so again, you can see here the response. Got a funny response here. I have to dig into that a little bit more. But what we're doing as part of this query is we're joining data from the Redis environment. We'll join sales orders from that Redis environment. We're joining customers between the MySQL and the HBase environment. We've got Dynamo and MySQL as well. So really starting to bring together those different tables or data that's stored in those tables. So it's really quite a simple feature to enable and start to play around with. So I encourage you to, if you do have that, data stores, and I'm sure you do have data stores stored in non-Amazon S3 locations, quite easy to get up and running. So I'll share these slides after this session, so more than happy to do that. So you've got a point of reference here, but just coming back to how do you get yourself started. Number one, make sure you're in US East 1. Number two, create this workgroup Amazon Athena preview functionality. Just making reference again, and we've spoken about this, so I'll move on quite quickly, but that registration-less federated query capability, so using using Lambda : as part of that, as part of your SQL statement, enabling you to not have to register your data source. And again, some reference to those connectors. So HBase, DocumentDB, DynamoDB, JDBC connector, which was what we were utilizing for our MySQL connector, Redis environment, CloudWatch logs and CloudWatch metrics. A really interesting use case here, particularly for the people who do operations and have to trawl through logs. So CloudWatch logs, or CloudWatch is our logging and monitoring service within the AWS platform. And so certainly these connectors enable you to utilize standard ANSI SQL to query your logs and your log data. So really, really powerful or different approach to log analytics, which you may be utilizing Elasticsearch, for example, today to do so. And then also from a data generator perspective, and this is part of your enabling you to, I guess, get more familiar with building your own connector. Now, a couple of things to be mindful of if you are looking to build your own connector. We've talked about the S3 spill location, a couple of other things around partition pruning, parallel scans, as I mentioned, being conscious of that, your downstream data source. The actual, language that we're using as part of the connector is aligned to Apache Arrow format, which is a portable column of memory format that we're using to perform that, the integration from a querying perspective. Other things to be mindful of: authorization and also that congestion control avoidance that I mentioned. Now, all this is available within that GitHub location. So it's probably me that's having troubles here. Has my connection dropped out at all? Am I still coming through okay?
Yep, you're coming through fine here, which is good.
Not quite sure what's going on.
The audio is good, but obviously the web page is not loading for you.
I know, and it's GitHub. It's very strange.
Perhaps are you able to perhaps share the link for that? If you could put that in the chat box, that'd be great.
There we go. That's
Thanks, Tom.
What's going on there? I will move along. So, and appreciate, there might be some questions. So let me just, before I get to those questions, let me just finish off on this slide. I'll take some questions around federated queries, and then we'll move on to a few other features that I'll touch on as well. And so, if you look at that, that notion around one of those use cases that we spoke about earlier around performing that lightweight ETL using Amazon Athena with some CTAs and into statements. With federated queries, it sort of expands that lightweight ETL use case that Athena can provide, enabling you to, if you are looking to move your data from out of your those data sources with minimal, ETL requirements, then Athena might be a great way to facilitate some self-service ETL for yourself or even people within your business. Cool. So what I might do is I might just let's take a look at. So there's lots of questions. I'll scroll right up to the top. So Tim, question around GA. So happy to share that under an NDA session. So for those who have contact with AWS, more than happy to just share a roadmap with you under NDA conversations. But yes, in public forums we don't share roadmap timeframes. But
that's okay. I'm just curious.
yeah. So it's been in preview for a while now. So looking forward to it getting it released formally in the wild. Yes, read between those lines on potentially when you might see it in GA, and happy to share that in more detail in a closed conversation. And for the broader audience here, happy to do that with you as well, providing that we have an NDA in place. Hamid, can we use this connector to other cloud providers' data sources? Yeah, that's a really interesting question, Hamid, because I think it certainly does touch on some of the trends we're seeing within the industry around, you know, the notion of data virtualization or data mesh. And so, you know, Federated Queries certainly has that capability to be able to reach into non-AWS data platforms, whether it's on premises or other cloud platforms and providers, to be able to provide that querying. I think at the moment, if you look at those provider connectors, you know, it's certainly predominantly AWS services, bar JDBC. But you know, certainly the custom connector, you know, it's certainly going to be quite interesting how our customers utilize that to build those federated or querying capabilities to the data sources that, you know, they require. And from an AWS perspective, you know, without a doubt, I expect to see that supported data source list to expand as we see customers utilize this service more and more. Is there a timeout limit? So I did cover that when in that deployment of the Lambda function. Is there the same Lambda timeout on every task we run with such a query? So the same Lambda limit on every task we run with such a query. So the Lambda limit that I showed as part of that deployment template for the DynamoDB. So those parameters are defined for that connector itself. And so you can, I guess, change those limits depending on those different connectors that or data sources that you're connecting into. So we're providing, I guess, default parameters that we think are probably best practice for those services, but certainly up to you to tweak as required. And for those who have a support contract with AWS, our support engineers would be more than happy to explore those with you in greater detail if you do run into some challenges there. How does Federated IAM work through the connectors? Can you manage per role access permissions on the federated source? Yeah, great question, Tim. So from a permissions perspective, the permissions execution is being driven through, so from a user perspective, through Amazon Athena. So from a query perspective, you can define the Athena access, and from a query at the query level, you can define that using IAM, an IAM policy, and a user can assume that a role that has that policy attached. Additionally, when you look at other permission levels, the catalog permission, so through Glue catalog, you can define those permissions aspects as well. And then for the actual Lambda function itself, so Lambda function does need to have access into or to those resources. Can the query processor optimize queries to push down predicates based on? Great question. I'm happy to follow up on that for you, Tim, around push down predicates. Sure. Off the top of my head, I'm not sure of capabilities today within the preview around that, yep. But certainly, yeah, happy to follow up on that one.
Sure. In the past, I've seen examples where you might have a table with 1 billion rows in it, and then you have a table with, you know, 1,000 rows in it. And if you want to filter those, then you could potentially query the small table first, and then apply that as a push down predicate to avoid scanning the 1 billion row table, that sort of thing.
Yeah, absolutely. Absolutely. Yep. Cool. Awesome. So I've got a couple of other features that, you know, sort of extend that that conversation around federated queries a bit, and you know, the first one is support for UDFs within Athena, and so very similar deployment pattern to federated queries, where this is being facilitated via AWS Lambda, and so enabling you to effectively write a UDF, deploy that within a Lambda function, and then be able to call on that UDF via an Athena or query in Athena. And so essentially what that looks like is within a Lambda function, you know, you can write your UDF function within that. We have its support for Scala today. And so an example here is we have a Scala function that's doing some redaction. And so essentially what it's going to do is take that input, manipulate the string, perform that redaction, and then return that. And so as part of the Athena query, you can start to call upon this function as part of that query. So if you look at this, the Athena query that's defined here, so we're going to be using this UDF name here. Within that query, it's going to invoke a Lambda function. This is the name of the Lambda function, and then within our SQL query itself, we are going to call that UDF function here, pass in that field, and then we'll return that redacted string as part of that. And we'll see a response light on the right-hand side here. So I do have that in a demo. So this is it here. So this is the same configuration here as per the slides. Let me run that. Oh, I've got some spinning wheels. Always makes me nervous. And so we will see, so what's going on here is we're executing that Lambda function, which has that UDF in there that we've defined, performing that simple string redaction. And that's being performed against, what's something else? That's being performed against the Redis table that's being joined with MySQL environment. And you can see here, we have our customer name that hasn't been redacted, and then the returned redacted string out of the UDF. So really simple example, but again, it starts to, I guess, expand upon or leverage the same, some very similar capabilities to what is being facilitated in that federated query piece. So that was a big ask by a number of our customers. Yeah, absolutely. I think this is being recorded, and I'm just looking at the chat here, and absolutely happy to share these slides with you as well. The last feature that I wanted to touch on, and again, this is extending the federated queries capability, is and comes back to that fourth use case that I touched on at the start, was utilizing Amazon Athena in the space of machine learning. And so, with the feature of inference support into an ML model, you can now utilize or call upon a SageMaker model endpoint to essentially do some pre or post data processing as part of a SQL query. And so, an example here, and this is starting to look very similar to the UDF, I guess, query. So what we have is we're defining a UDF that is not a Lambda function this time, but is a SageMaker endpoint. And then we define what that SageMaker endpoint's name is. And then within that, you can pass that, I guess, the field into that detect anomaly function here. And so what this example is, we're just doing an anomaly detection against a data set. And scoring that data and presenting it back. So I have that as a demo as well. Oops. Hang on. Sorry. So what I've got here, let me just show you from a SageMaker perspective. So for those who aren't familiar with SageMaker, think of SageMaker as a machine learning platform for you to really, I guess, enable you to build. The goal is to build, train, and deploy models quicker as a data scientist or a machine learning engineer. And so SageMaker itself is a platform of capabilities where you can get access to a hosted Jupyter instance notebook environment or Jupyter Hub environment, and enable you to automate the labeling of your jobs, your data through ground truth, perform some simple distributed scaling, distributed training at scale, and then also one-click deploy notion of your deploying your models in behind a RESTful API endpoint, enabling you to make calls from an inference perspective. And so what I've done prior to this is I've stood up a Jupyter Notebook instance where I have my anomaly notebook it's stored here. I won't launch that in the space of time. I've gone through a training job as part of that. I've deployed an endpoint as a result of that model. So using, it's a simple RCF model here where we're doing some anomaly detection. And so this is the name of of the endpoint that we want to pass into our query that we're going to run in Amazon Athena. So if I jump back to Athena, and I have one that I've pre-made earlier. So what we have here is a similar query to what we had on the slide. So we've got that UDF, which is essentially calling as that SageMaker endpoint, and I've put that endpoint in here. We'll just run that query, and then running that SQL statement here. So this is, has been a massive ask by our customers, because when you think about trying to integrate machine learning into your day-to-day operations or capabilities for your BIs, for example, to utilize those ML models that you've trained, being able to bring that into SQL, as opposed to people who may not be familiar with interacting with models through other mechanisms, it can really, bring that closer to those engineers or analysts who are looking to utilize it. And so you can see here on the, as part of that response, on the right-hand side here is our RCF response around that standard deviation of that anomaly detection, and enabling you to, again, get that response from that query. So this is not using AWS Lambda.
Sorry, I think we might have lost Tom there.
Lambda within.
Tom, you're breaking.
You're breaking up a bit there, Tom. We seem to have lost you for a bit.
So you don't have to worry about deploying. Really, really cool feature.
Okay.
Oh, what am I back?
You're back now. We can hear you again, but you dropped out for a few seconds there.
Did I? Where did you hear up to?
I think you were just finishing off talking about the query and how you can use that to do anomaly detection, and it was something that was requested by a lot of your customers.
And then
I think you got most of it. All good. And finally, just what I've done is I've just put together some reference links for the team to if they're really keen to dive deeper into it. So some reference links of those 3 features that we explored today, but also that top 10 performance tuning tips that I mentioned at the start. That for those who are using Amazon Athena or looking to use Amazon Athena, this is a great one to have in your back pocket, just to ensure that you are getting
Tom, you're breaking up.
the best performance, but also making sure that you're using it in the content. Is there any further questions? My apologies. I'm back. Looks like I'm back.
Yeah.
Apologies. I think this time of the night, people are streaming TV.
Big demand.
Yeah. But yes, any further questions before I wrap up tonight?
Folks, please feel free to unmute yourself and ask, or maybe, if you don't have questions right now, maybe you can reach Tom. Tom, how can people reach you if they want to?
Yeah, absolutely. So I'll drop my email address in the chat here. So feel free to drop me a note directly if you're looking for any further information around what we explored tonight, but anything else, happy to connect you with an SME or get that question answered for you. So by all means, reach out. More than happy to help.
Fantastic. Thank you very much for that, Tom. I hope everyone else has found that as interesting and stuff as I have. And yeah, there's a lot of really powerful things to explore there. which is really good. We might keep going with the meetup. There's a couple of slides here. So thanks again, Tom. There's some links there, and I think we should be able to share some of those links on the meetup page as well, for anyone that wants to follow up afterwards and look at some of those references and stuff that Tom shared with us. We're going to step in now to the marketplace. So this is an opportunity if anyone's got some cool tech that they want to share, or a project they're working on. If anyone's looking for work opportunities, or someone's got some work opportunities and looking for some people to assist with that, this is your opportunity to shine. So we're offering a 60-second slot for anyone to unmute yourself and tell us a bit about your project or your link or your things that you're looking for. And I suppose we're also adding, just before we jump into that, perhaps Harmeet, would you like to share with us a little bit about XConf?
Yeah, if no one has anything for community marketplace, that's so ThoughtWorks is ThoughtWorks Australia. It's organizing organizes a yearly conference which is called XCon. So this time it's more about, Martin Fowler is talking. They have a keynote, Scott Shaw, and I'm not sure if you've heard of Zamak, who has basically conceptualized data mesh. So she's also presenting, and we have a couple of talks where we are talking about some of the machine learning operations, and as well as some of the actual machine learning stuff. So there are all in all 6 talks. So if anything interests you, please feel free to register. It's free. It's on 10th September. And I'm also presenting one of the talks. So yeah, thanks.
Fantastic. Thanks, Harmeet.
Thank you.
Just back to the community marketplace. Does anyone have anything they'd like to share?
Yeah. Hello, everyone.
Hello, Timmy.